Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. Thanks so much for joining and watching this video. Thanks to those who have recently subscribed. I really appreciate it. And I hope if you find this video helpful, you'll give it a thumbs up, consider sharing it with others, consider subscribing to the channel, and click on that notifications bell so you know when other videos are available. In this video, I'd like us to take some time to look at one of the 5 strands of math proficiency called adaptive reasoning, and some of the things you may be seeing in your young child's math classroom that's really helping to develop that proficiency, that area, okay, that strand. So if you look, one of those 5 strands, and I'll put a link in the description below to the video on the 5 strands of math proficiency, but one is adaptive reasoning. And that's that ability, the capacity for logical thought, reflection to think about answers making sense or not, reasoning through things, explaining your thinking, defending your thinking. Right? Now, quite often, we'll have children who feel quite confident in their answer. They're really good at procedures. They really know their facts, and that's important. The struggle is if we ask them, how did you get your answer? Or how do you know? And you may have heard this from your child at some point. They'll often say, I just knew it. My brain told me. That I'm good. Yeah. See, it's such a part of them, those facts and procedures. They have a hard time thinking about how to defend their thinking, explaining it. And one of the things you may find happening in your child's classroom is trying to get them to move beyond, I just knew it, my brain told me. Because we need your child to think about who their audience is, right? What is that audience they're talking? Who are they talking to? And when they say something like, I just knew it, or my brain told me, they're really talking to an audience of one themselves. It's not helping any of their peers, any folks that they're interacting with, understand why their solution is a correct one or makes sense. And you may find the teacher purposely doing things to not be the answer key. So that's important for us to think about at home too, when you're helping your child with homework or things, and they'll look and say, am I right? We want to shift from us being the answer key to say yes or no, to them convincing us that they're right. That's an important step in this area, in this strand for proficiency. Now, one thing that's very important is rigor, right? Being challenged enough, having that depth of understanding enough that we're going to be successful in that 21st century, right? And one of those really important skills is imagination. So you may see things in your child's classroom that at first sight might not look like it's very mathematical. But part of that imagination, seeing things as wholes and as parts and reasoning. So this is a pre-kindergarten level classroom. And this is a photo of a time machine that the children built. Just constructing something takes a lot of thinking, but you might see clocks on the machine. You might see things in this classroom where the children decide they're going to travel back in time, and they might have built a village underneath that loft area. They might have dinosaurs that they're finding and exploring and acting like young archaeologists also. And think about when you find dinosaur bones, you might use a grid to indicate where you found them. All very mathematical, but it's also helping build imagination, picturing things, how they might work, what they might do. I know of some schools that have been using this book, Purposeful Play, and I got a chance to look at that play. And the one thing, or at that book, I guess I should say, one thing that struck me was this idea of substitution. When you watch young children play, they build things with blocks. It's not uncommon for them to have trucks inside a house. I saw that once. The child had a small truck inside the house, and I said, oh, who is that? Or what is that doing in the house? He said, oh, well, that's Grandpa. or that's the father, or they substitute blocks to represent other things that the block doesn't look like. It's very common during play to do that. That's a really important mathematical idea. See, when they start to understand that I could use a single object to have multiple meanings, we use that when we use variables, right? We use a letter that could represent multiple values. We might use a box, we might use a star. We might use a drawing, and the drawing might just be circles. And one time those circles represent fruit, another time it could be animals, another time it could be cars. We need them to understand that we could use an object to represent multiple things. So when they are playing, that's an opportunity when they first start to develop this idea. So as I said, notice early, first grade equations, missing add-in equations. What did we use to represent our unknown? We could use a line. You might see a box on your children's paper, and we're trying to build that. It's a substitution, isn't it? I'm letting a box be the unknown, a line be the unknown, a letter be the unknown. And then that letter can have a value. As they move up through the grades, they'll understand that sometimes these letters are an unknown, a single value. Sometimes it's variable. It could be a range of values. We expand their understanding of these uses. And then later, even they use substitution in algebra, right? They might have this algebraic expression, 3x squared y plus 2xy minus 5. And then they're told, well, x is 3 and y is 2. What's that value of that expression? They're substituting in, okay? But that understanding begins as your young pre-kindergarten child is at play and starting to think about how I could let something represent something else. It works just fine. It's important for us to realize that happens and help build that connection. Now, I just want to share, this is a game that comes from one of the programs. I believe it's called Bridges. The Math Learning Center did it. They are not endorsing me. We are not affiliated in any way. But I was in a classroom that was using this type of an activity, and this just happens to be their sheet. You'll see this in other programs where they have a material called pattern blocks, and they're filling in a shape. It could be a rhombus, as this is. It could be a hexagon. It could be a trapezoid, and you can see in their graphic different shapes that are the pattern block shapes. There's also a video I'll leave a link to that looks at different models your children may be using in school, and you'll get to see some of the ways in which pattern blocks are used there. But in this particular sheet is used as a game, and you can see where it says last shape wins. The idea is that the children play with a partner, or they could play as a threesome, a triad, and they take turns putting one of those pattern block pieces into that puzzle outline. And the goal is to be the last shape to win. Now, see, when your child first starts playing games like these, you may see this with your children who play games. They're first just trying to figure out what the game is. They're first just putting pieces down, and sometimes in this game, they are surprised, right? They're surprised that they won. When it comes to that adaptive reasoning, right, the logical thought, we need to kind of progress this. I think of it in phases, but at first, that's perfect. Just letting them explore, just letting them get the hang of what's happening. But then I can kind of nudge them into thinking about things. Now, you notice this puzzle has been stopped with those two holes in it. And one thing you might see teachers doing with the children is they will bring this up to have a class discussion, right? They bring the kids back together quite often on the carpet area, circle time. I believe this was a first grade class we were working with this on, and they have those pieces missing. And I had the opportunity to do this, and my question to those children was that it's my turn, but I want to win. What piece should I play? Now, if you look at those holes, you'll see that that trapezoid piece, that red trapezoid shape, would fit in one, and the green triangular shape, that prism, will fit in the other hole. But if I play either of those two shapes, I'm going to lose because my partner will be able to play the other one and win. See, I have to think of a shape to play that will still give me a chance. And quite often you'll see teachers using a technique, it might be called turn and talk, discuss with your partner, heads together. You might see different techniques used, but we want the partners to have a chance to talk. Because if your child is always talking through me, it's only one child gets a chance to talk. But when they use that turn and talk idea, right, it gives a lot of children a chance to talk and to discuss ideas. And it's important. And I had one of the children as my partner, and this little girl said, "Oh, you should play the triangle." "Nope, I'd win." "You should play the..." "Nope, I'd win." "Oh, I know, you should play." And she had me play the blue piece. If I had played the green piece, the triangle, and I know you can't see where I'm pointing, I could put it down in that bottom hole. I could put a triangle up in that other hole, but then my partner could play a triangle and I'm going to lose. But if I played the rhombus shaped piece, that blue piece, up in that top hole, the only choice my partner has is to put a triangle in one of those two remaining holes, and I'm going to win. It's that logical thought. It's thinking ahead. It's making a prediction of what's going to happen. That's what adaptive reasoning is. So at first, playing the game and realize, oh, I'm going to win. Great. But then getting to a point where you start to plan your moves so that you can win is an important part of this strand of proficiency. Now, as I said, at this point, we stopped the game and had those holes and got them started to think about it, right? They're starting to think about that whole thing. Now, when they play the game again, because quite often you'll see your children playing the game repeatedly, but one thing we want to think about is how do we increase the level of thinking? But when they play this game again, they already get the hang of what it is. I might say, I want you to think when you know you're going to win. See, that helps kind of promote that strategizing we want them to do, that logical thought, that reasoning and planning ahead. And the turn and talk gives them a chance to think about. So if you're playing a game with your child, pause and ask, gosh, what should I do so that maybe I could win? Or what do you hope I do so that you'll win? Get them thinking about it and just talking about it, right? Learning that language they need. So we know there are great thinkers who understands the importance of play, the mind, but it helps them with that reasoning side of things. They're thinking through, and sometimes they may be using physical objects. Sometimes it's the playing of ideas. It's thinking ahead and understanding that there's more to it than the first domino that falls, right? Have you ever made the domino trains where you push a domino and they all start falling? It's being able to start to think about not what happens with the first domino, but what starts to happen 5, 6, 7 dominoes down the line or further. So, part of what you may see is helping your child develop a critical eye. And you might not think it's very mathematical again, but in this case, we might be asking your children to draw pictures like this child is doing. They had a big sunflower, they're drawing it, and then you notice she starts to pull it apart. But when you draw pictures, you notice details more. You see the whole, you see the parts. So you might be seeing activities for your young children to develop the critical eye, to help them plan ahead, to help them think about why things are working. You might see your children spending a lot of time talking about how things are the same and how they're different. See, it's easy to talk about differences between two objects, but it's quite challenging to think about how two objects that are different are also the same. And you might see them doing it where it's just a single difference, or at least these are two toy cars, two toy trucks. But you also see them looking at things to explain differences that lead to change, because change is an important algebraic concept. So you'll see them doing that. And in young children, it might be with leaves. Qualitative changes. It's not always about number. It's also about how things qualitatively change that helps them understand the patterns. The graphs they'll see later when they get to algebra and even calculus, what's happening to these things. Why is there a maximum here or a minimum, and what is changing as we look? You'll also see them doing things with patterning and a progression that occurs. But one thing we want your young children to do is always look for patterns, patterns in the world around them, patterns that eventually occur with sound, with movement, with number, right? We want them noticing them and naming them and copying them and extending them, and even seeing a pattern that might have been made with colored blocks, like a red-blue pattern, but then using fruit language to describe the pattern. Apple, banana, apple, banana. So they're still seeing red, blue, but they know they could use different language. They could substitute in again. They could use animal language, dog, cat, right? That they understand that I could use other objects to represent a similar pattern. So I hope this helps explain why you're seeing things. I hope it helps us see why, with developing adaptive reasoning, that focus in on logical thought, considering your audience, understanding that being proficient at math is much more than just getting an answer quickly. It's being able to justify your thinking, defend your answer. You'll think about critiquing the reasoning. Does what they've done make sense? That's that logical thought again, right? And then it's looking for those patterns and always thinking about how things that are different could also be the same. Notice how with adaptive reasoning, it's thinking. And there are some things I hope you've seen that we can do to help your children get more and more comfortable with the reasoning side of mathematics. Again, I hope this helped. If it did, please give it a thumbs up. Please consider sharing with others. Consider subscribing to the channel. Click on the notifications bell so you'll know when other videos are available. And thanks so much for watching.